was 12 years ago, almost to the day, that we got this 2007 Jeep JL Wrangler Rubicon Unlimited that most of you know as Moby. And it was 10 years ago that we got him his very first Dynatrac product, a ProRock 60 front axle. Now, since that time, we've been able to rack up well over 150,000 miles, driving him all across the United States, and of course, wheeling him all along the way. Now that includes taking him out on dirt, across the sand, through the snow, into the mud, out on the rocks, and of course, bombing our way across the desert. While it may not look as pretty as the day we got it installed, what is worth noting is that everything that you see is all original. That means the ring and pinion, the lockers, the axle shafts, and U-joints are all the exact same things that we've been running all this time. Of course, it's because of this long resume of use and abuse that Cindy and I were convinced a Dynatrac was going to be the axle for us when it came to upgrade the one on our Jeep JL Wrangler. As hard as it is for even me to believe, it was a year ago today that we picked up this awesome JL Wrangler Rubicon Unlimited. And now that we have over 20,000 miles on the odometer, it was time for us to make a change to it, and one that would give us peace of mind to push it even further. I am, of course, talking about upgrading the front axle to something a bit more stout, and after the decade of abuse that we've put on Mobies, we knew that there was only one name for us: Dynatrac. For our purposes, we're planning on sticking with 37-inch tires, or at least for the time being, and so we're opting to get a ProRock 44, which is more than up to the task and is really the perfect axle upgrade for those of you who've got a Sport or Sahara. So let's go check out how it's made. They're called in.
Punctual. Man.
Are we?
Yeah, 7:01, man, right on the button.
Well, actually, we were outside filming for a little bit, so
really?
it's all good.
So you've actually been here for a little while?
Yeah.
Good. Very good.
Come on
in. See you, Cindy. Come on. How you doing? Come on in.
It's all shiny new. Is this thing even used?
Yeah, actually it is. So, you know, this is like the first prototype we did for the ProRock 44, and then we had it in our JL for quite a while, and we were working on some videos, just doing some installation, you know, shots, and we just had one of the guys, you know, give it a quick zip job, you know, so it
looks brand new.
So it looked newer as it went back in. So, but
awesome.
even this has changed up a little bit, and yours is going to have a couple different features.
Well, cool. So I'm obviously here with Jim McGee, the owner of Dynatrac, and this is the ProRock 44, or essentially what we're going to be installing on our JL. Can you tell us a few features on here that our audience might be interested in hearing?
Sure. So obviously the ProRock 44 is, its number one job is to resolve any concerns, issues, fears, or uncertainties about housing strength, right? So there's already been a number of JLs that have had total, you know, housing failure where they literally break in the middle, and that's pretty disconcerting to people, right? So that's really our number one thing, is make a housing that people, even if they have a mishap, you know, you're cruising along and you get distracted and you look over there at a burrow and then all of a sudden you hit some big hole, and when that happens, you know, you want to be able to, you know, be shaken up but not have your vehicle disabled, and so that's what we're focused on here. So obviously we've upped the tubing from the JK, and that's to do really two things. One, we found that after we analyzed all our JK sales, the thick wall tubing options were the most popular thing. I mean, by far, everybody went with that.
And by thick wall, what are we talking about here?
Half wall.
Okay, so, half wall. So, and the diameter of the tube is?
Well, it was 3, now it's 3 1/8.
Okay.
So this tube is now actually the same tube dimension we've had for all our ProRock 60s before the XD. So if you had a first generation ProRock 60, it had 3 1/8 half wall. And now the ProRock 44 for the JL has that too.
So this is actually a really cool comparison for you guys to see. This right here, this 2.5 inch by 1/4 wall tube, this is what used to be on the JK. You could find this on the Sport, Sahara, or Rubicon axles. This is what you would see on a JL front axle. Again, Sport, Sahara, or Rubicon. And this badass, this is what you'd find on a ProRock 44. Which would you rather run?
One of the other things is that's actually makes the strength of this equivalent because the JL is wider. So things have gotten wider over time, right? So you had CJs that were like 56 inches wide. And then we have YJs that got to be 60.5 inches wide. TJs were 60.5. JKs went to 65.5. And now we have JLs at like 68. So
right.
it's all, you know, keeps getting wider. As it gets wider, that puts more leverage on the housing. So,
sure.
you know, we're trying to make sure we keep up with that strength level that everybody's come to know and love.
So like one of the things that I've always loved about the ProRock 44 is the fact that it had always boasted having the most ground clearance thanks to the profile design of it, of the differential housing. Is this the same with the JL housing? Because I know it's a little bit different now than what was on the Dana 44s.
Right. So ground clearance on the ProRock 44 is as good as ever, and it is still best in class. Nobody touches us on that. So the patent that we have on the ProRock design is embodied in the ProRock 44, in the first generation ProRock 60, and in the XD60. That hasn't changed. So that's really one of the main benefits, right? So if you're swapping in a ProRock 44, you're getting a number of things, right? You're getting a much stronger housing that's not going to let you down. You're getting a big improvement in ground clearance. Also, the underbelly of that ProRock 44 is a lot smoother, and so it glides over things a lot easier. It does not have that troublesome drain plug in it like their stock axle does.
Really?
Yeah, so it's, which, you know, I'll be honest, I've had friends that have had problems with drain plugs in houses like on Toyotas and things, right? So I'm not a big fan of that either. The other thing, of course, is we had heavier end forgings on the JK versions of our ProRock 44 because the end forgings were bending. Well, the JL, you know, takes a completely different end forging to mate with the JL knuckle, and so we redid all that too. And so you still get that big, strong end forging as well.
So in regards to our purposes, how much, if any, of the factory axle are we going to be reusing?
The only thing you're going to it depends on, so we're going to have different shaft options, and so right now the two shaft options we're going to go through today are the basic one, which is the 1350 class U-joint, which is what you see here. You can get RCVs, and then we have some other stuff coming out down the line. So you'll use your outer stub axle, perhaps, or maybe not, depending on how you purchase from us. Your knuckle, your wheel bearing, and your brake assembly. So it's very much the same as the original JL.
Okay, so then the ball joints that come on here, standard, are they just the JL?
That's the stock ball joint.
Okay, gotcha. Okay.
Right. On the JK, we have our Pro Steer options. We do not have those available for the JL at this time.
Got it.
The gears that we're using are JK gears. So that's one of the things about the ProRock 44 that we felt was important. The JK gear set is been around for a really long time. It's very well tested, and there's also a lot more diff choices available by doing that. This gear set pumpkin combination has been working so well. We got thousands of these out there, and they've been really trouble-free for everybody. And so we just want to stick with what works.
Awesome. So for guys who have a Sport or Sahara, your axles are actually slightly narrower than what you'd have on a Rubicon. Can you actually get this in either a Rubicon length or?
Absolutely.
Okay.
Yeah, absolutely. Because, you know, I think if we make it wider for you, and we've had customers ask this, so should I get it wider now and then maybe, because I'm probably going to get a rear end from you? And the answer is, yeah, you can do that. There's not really a problem with that. Now, obviously, if you stand from the side of the car, you won't even really notice it. If you stand behind the car and eyeball down the side of it, you are going to notice it. Now, is it going to be so terrible that it's going to cause a problem? No. I mean, in fact, for years, OEM vehicles all had wider front ends than rear ends. I mean, so it's not new. It's been like that in the past.
Our CJ's like that.
That's right. Right. Particularly back in the day, leaf spring vehicles.
Oh, yeah,
so
of
they made
course.
the front ends wider so that the tires wouldn't rub the springs.
Exactly.
And there's lots of other reasons too. So.
How about in terms of weight? Like, what kind of weight are we looking at in terms of this front axle?
Well, that's a good question. I don't weigh it.
Oh, okay.
I don't know. Let's go weigh these and subtract it from the numbers they got. And
Okay.
we shall have a pretty close, pretty accurate picture.
We're trying to get a total weight analysis of how much more a ProRock 44 weighs in comparison to a factory 44 or the M210. Trying to be accurate. Yeah, look at all these axles. So the shafts alone weigh 36 pounds. We're gonna add that together into the housing itself and the gears and everything else to get a total weight. Okay, so we just got some numbers for how much everything weighs. How much did you say the 186 weighs?
So the Dana 30 front is about 130 pounds, maybe 135.
And the 44 or the
About
210?
170 to 175.
That's a 40-pound difference-ish.
Yep.
And how much does a ProRock weigh?
This is about 210, maybe 215.
So another 40 pounds is
Yep.
what we're looking at.
Yep.
Perfect. So where do we go from here?
Okay. Wait for everybody to come back from break.
Okay. Perfect.
Yeah.
Gotten all my
Wait,
life.
what was that? You have to
Say it
that.
again, yeah.
You have to say that.
I say Eddie Spaghetti is better than Stevie Wee Wee.
This is my good friend Steve. He's going to be helping us out today. So we just pulled in our JL, and so now what are we going to do?
So we're going to have a couple guys start to deinstall the front axle that you have, and then we're also going to get started on opening up, doing the surgery on the rear axle to change your gear ratio.
Awesome. Because we're going to be running 513s and our front axle, we actually need to re-gear our rear axle as well. Fortunately, Dynatrac was nice enough to help us out with that. So we've got our JL on the lift, as you can see right now, and all the wheels and tires are coming off so that we can get that squared away. I should note that this isn't something that they normally do. It's not like a customer can come here and actually get this done, but because they're good friends of ours, we get a little extra special treatment here. So what are the very first steps that we're going to do in order to get this axle built?
Well, we can actually start from a few different places, but you know what? Matt's getting ready to machine tubing for you, so why don't we just jump right to that and get a look at that.
Cool, let's go. Long time no see.
Good to see you.
You as well.
So Matt's going to do a piece of tubing for us. That's going to be one of the tubes for your ProRock 44.
On these JLs, we're using a 3 1/8 half wall.
You know, even more than the samples that we were looking at earlier, when you see it in its entire length, that's a heck of a tube.
Machine the tube for the end forging. I'm going to flip it around and do the pumpkin press side and the seal bore. complete JL short side tube with your end forging machine with your interference fit, the pumpkin press machine with the interference fit, inner axle seal housing machined board with the interference fit. That's it.
All right, so we have our tubes all machined, and now we're going to put our end forging and our seal housing in there. The end forging is pressed onto the end in this press, and it's pressed on to make sure that it's square and it has a tight fit so it can never come off.
This is Eli over here at Dynatrac, of course, and he's going to be putting together the first pieces of our axle. And so where do we start?
Tube here, get end forging pressed on there, seal housing. I was telling these guys that I was gonna come in and cut my hair like yours, but I thought it'd be funny, but I ended up not doing it. Get this welded, and then we'll get our axle pressed.
All right, now we have our brand new JL end forging pressed on the end of our tube. Now we're going to weld it. To weld it on this weld positioner, we use a special wire that's made to penetrate deep into the base materials and fuse those two pieces together. And essentially we have a very big welder that does that, so we can really apply a lot of power to it and get good penetration and a good fused weld.
How long did it take you to learn how to weld that nicely?
About 5 years.
Yeah.
So, yeah.
That looks nice.
Thank you. It's not going anywhere. It's on there for good. We're gonna go grab a pumpkin and get your axle pressed.
Awesome. Do I get to choose?
Sure.
So Jim was telling me that I get to pick my own housing. What?
That's the one you want right there.
Oh, this one looks nice.
You like that one?
Let's get that one.
It's the one that was ready to go.
All right, so we've got the basic building blocks of our housing done. We have a pumpkin, we have two tube assemblies. So that's three major components. The short tube, the pumpkin, and the long tube. Now what we're gonna do is press those together. The tube's been machined, the end forging is already welded in place. Now we're gonna set the cast to pinion angle relationship in the press.
How you doing? Just hanging out? Yeah. So right now Eli is setting the tubes in the differential housing so that it has the appropriate amount of caster on both sides.
check it all twice just to make sure. All right, that's good.
So now we're going to be pressing in the axle tubes into the differential housing itself.
So get the spreader out, and then get this thing milled, and then go get it over to John.
So this process involves drilling holes into the differential housing so that rosette welds can be put in place to prevent the tubes from spinning.
Tricks to go deep enough but not too deep, so I'm just trying to see you might be able to get a shot of that. So you don't want to go too deep, but once you're hitting the steel of the tube, that's where we'll stop.
How many holes do you drill in total?
12 holes.
So 6 on each side?
6,
Got
correct.
it.
So John's gonna take it from here, get some brackets on there for you.
All right, so now that our housing is all pressed together, we've set the pinion angle and the caster in relation to one another. The next step is to get the brackets on the axle housing and make sure they're all positioned correctly so that when it goes in the car, everything fits and bolts up. So the fixtures that we have are set up to do that. The housing goes into the fixture and it's located on axle center line. Every bracket is all located off a axle center line and vehicle center line. So we're building from the very middle point out. right, so we're all pressed together, and we want to make sure that those tubes stay permanently locked into that pumpkin. So we're going to put some Rosette welds around the trunnions where the tubes are pressed in. Those welds, basically, think of them as an electric bolt. So we basically are welding deep into the bottom of the hole and fusing that weld to the tube material and then letting it bubble up. We're not really welding the casting to the tubing. We're more or less creating a big solid rivet that's fused to the tube and holds it in place.
We're back over at our JL right now. Steve's taking apart the rear end. He's going to start setting up some new gears for it. Hey, have you installed any new gears on the JL yet? Is this the first time?
This will be the second time we did it on our own Jeep, so it's a little different. Carrier bearings, shims, 2 different sizes, so.
Of all the people that we could have working on our gears, Steve is the guy. There's no other master technician that I know of that can do gears in his sleep the way he can. Look at the size of the bearing on the driver's side versus the passenger side. Considerably smaller and larger. Steve is telling me that this is actually something you'd see more like in Toyotas. Every other Jeep in the past, JK, TJ, or otherwise, would have had the exact same bearings, and all the shims would all have been the same as well. So this makes it a little bit more interesting. So this is what came out of our JL?
Yeah.
So is there reasoning behind that?
Yes, there is. All right, so what you can see here is new bearings, right, that you see on the JL. So there's a few things here. One, you can see there's a crush sleeve, all right, and it's a little dirty, but it's there. The other thing is you'll notice that we call this the preload bearing, and this is the inner pinion bearing. So this bearing locates the gear in relation to the ring gear, and this one basically rides on the shank here and opposes. It's a little tight, so I'm not going to put it on there, but sits right here, and that's what keeps the pinion from moving in and out. Now the reason they're going to ball bearings is primarily because they can reduce friction, and reduced friction is good from the standpoint of, you know, really minute amounts of fuel economy add up. So if you get 0.0 0.05 miles per gallon, that starts to add up. So there's no big silver bullets that just like give you like 3 miles per gallon. So you gotta work pretty hard nowadays to get stuff out. And these roll very freely, and they're very low friction because they have such a low contact area. The ball touches a much smaller area than, say, a tapered roller bearing. But generally speaking, ball bearings are not viewed as a high load bearing. So these tapered roller bearings are. The ProRock 44 has tapered roller bearings, inner and outer, and it's just a better load carrying setup, and it works really well, and we're not worried so much about fuel economy, and we're lucky that we get to do that.
Yeah.
So.
That was cool. Because we're going to be reusing some of the front end components like the tie rod, drag link, track bar, and even the brake calipers, brakes themselves. A few other components. We're going to have to remove our front axle so that we can get all those parts off of it and installed onto our new ProRock 44. Okay, so what's up next? What do we do now?
All right, so on this side of this building, we do all the assembly and gear work. So that's what's coming up next. So we're gonna introduce you to Noah, and Noah's gonna be doing all the gear setup and the diff installation.
Awesome.
How you doing?
Good, man. Good. This
Real
is
pleasure.
See you.
Where do we start?
Well, first thing we're going to do is install our factory tube seals.
And then from there, it's a basic gear setup. We're gonna knock races in. We're gonna install the pinion, the carrier, leak test it, run a pattern. Pretty simple.
Awesome, let's get started.
Okay. Okay, so this is our bearings that come with the ring and pinion kit. So we've got our 2 carrier bearings for the ARB. This comes with the ARB, obviously. Here's our 2 pinion bearings, the outer bearing and the inner bearing. Doesn't matter which one you start with, we're gonna start with the outer one, but before we install this, we're gonna put our oil baffle in. It's very important, especially on a high pinion front end. This is gonna slow down the path of the oil temporarily. So very important to always put this in. Since we're installing an ARB, we're going to drill and tap this hole for the ARB bulkhead fitting. So the air line is going to run through the differential, out this hole, right next to the upper control arm. So now that we have the ARB bulkhead fitting drilled, tapped, we're going to move on to the pinion installation. This is our pinion gear, just a typical JK44 gear. We do something a little different at Dynatrac. Normally from the factory, you've got a bearing that gets pressed onto this bottom surface. That's your inner bearing. And between these 2 bearings is a crush sleeve. Now, there's some benefits and drawbacks to this. Most of the benefit is coming from the factory. This is kind of a one and done deal. A lot of guys, if you know Jeeps out there, when you install these, you're gonna run these bearings together with a pinion nut, and it's gonna crush this collar down to the appropriate preload. And preload is obviously just the amount of force it takes to spin this gear. But at Dynatrac, we don't like this. We're gonna eliminate that. This is gonna actually take up the place of that crush sleeve. It's a solid metal spacer, and we use preload shims between the 2 bearings to adjust how much force it takes to turn. The benefit of having this is that this will never crush. You'll never lose preload. If you ever have to change a pinion seal, usually means you got to take the whole gear assembly apart, and then you've got to buy another one of these. And not every guy out there knows how to do gears, of course. And you shouldn't have to actually go through that process. So with a crush sleeve eliminator, if you had to change your pinion seal, all you'd have to do is pop the seal off, put a new one on, re-torque your pinion nut, and you're good to go. Because this will reset the torque exactly where it left off. So now what we're gonna do is, this is our pinion depth shims. This is gonna set the distance between this pinion gear and this ring gear, the mating surface. We're gonna start with this, and hopefully so that gets us the appropriate pinion depth. Move this on over to the press. Okay, so now that we have the inner pinion bearing pressed on, ready to go, before we put in our eliminator, we're going to add some preload shims. right between 20 and 30, about 25 inch pounds. So that's perfect. So now we can move on to the carrier assembly. So this is our ARB locker, and on this front end we're going to be putting in 513 gears. Now before you install any ring gear, you always want to make sure that the surface is completely flat, completely smooth, no burrs, no pieces of metal, even a piece of fabric underneath these two mating surfaces can throw off the level of the gear. Plastic mallet. So now that these have got a little bit of threads, what I want to do is just knock the whole gear down so it's flush with the bottom of the carrier. So if you do this properly, all the remaining bolts should just thread in by hand. If you feel anything biting or kind of out of whack, that usually means that the gear is off with the alignment or it's off at an angle. Just double check, make sure, take your time. So now, let's go ahead and take this over to our fixture, and we're going to manually torque down all these ring gear bolts. Alright, so now that we have our ring gear bolts all torqued down to spec, we can go ahead and install our carrier bearings. Okay, so now that that's done, since this is an ARB, you'll notice there's a tiny air hole right there. That's what's actually going to activate this locker. Air is going to come through here, it's going to collapse and lock in a gear. It's going to lock both of your side gears together, which gives you the spool effect of both wheels turning exactly at the same time. So this is our seal housing. Your kit's going to come with O-rings. I'm going to put a little bit of grease on these just to keep them in the seal housing. Between the bearing race, the seal housing comes with a ARB master shim. I'm going to install that between the two surfaces like that. And there you go. Once you have it in about halfway, you want to be able to feel the pinion teeth engage with this. If you start to feel a bind, try to back this off, pull it back out, readjust, or turn the pinion itself. Now that it's fairly in there, you can go ahead, grab a mallet, and install. I don't feel a whole lot of backlash, but we'll double check. If that's the case, if we don't have any backlash, we can swap these shims on either side to move this carrier away from the pinion gear. That'll give us some backlash. So right now, almost nothing. That's fine though. So we're gonna take this back out, adjust our shims, and then we'll see what happens.
So can you tell us what backlash is and why it's important?
Backlash is probably one of the more important things on a ring and pinion setup like this. Not every gear that you buy is going to have the same backlash rating. On Dana 44 gears, usually it's somewhere between 6 to 10 thousandths, and what that means is the gap between the two teeth, that's the spacing that allows oil to get in between these gear sets. If the backlash is too tight, there's no oil there, there's no lubrication, and then you'll have gear failure. If they're too far apart, what ends up happening is you've got this wind-up effect. You've got the power of the engine gaining speed and that pinion gear slamming into that ring gear, and eventually it'll break teeth, make noise. So getting it just right is what you really have to do. And I'd always recommend getting your backlash dialed in and correct before you check any gear pattern or anything like that, because you'll just be chasing your tail. Okay, so now that we've got the carrier back out, I've changed some shims. We ended up adding about 3 or 5 more to the right-hand side to move the carrier in this direction to give us some more backlash. And I'm pretty confident with this measurement, so I'm going to go ahead. We're going to open up the case. We're going to use this case spreader. Now, when you use these, you got to be very careful. You want to open this case no more than 20 thousandths. I think I'm going to go about 10 thousandths just to get the proper preload. Kind of hard to hear, but you can hear the backlash, and if you're really good, you can guess how much it is. So we're shooting for, like I said, somewhere between 6 to 10 thousandths. So as long as we're within that range, we'll be okay. Then we can run our pattern. So let's check our backlash. It's like 6.5, which is fine. So what you want to do, find a spot on the gear. I'm going to take some of this gear yellow marking compound. We're just going to mark the teeth, brush these in a few places. You want to make sure you get both sides as well. Okay. Not bad.
That's pretty clean.
So what you want to look for is you want to look for a nice symmetrical pattern on both sides, on the coast side and the drive side. It should kind of look like an eyeball, like a nice oblong shape. And it looks pretty good on both sides. That's it for the gear installation part, and then we can move on to install our airline, our bulkhead fitting, leak test it, and go from there.
Awesome.
Okay, so just to wrap up, we're going to reinstall our main caps. We're going to remove our sit-up yoke, install our baffle, and our new pinion seal, and our new 1350 yoke.
Looks like we're getting close to the home stretch of getting this axle built. All we've got left are the ball joints and axle shafts.
So let's go ahead and install our factory ball joint. Now that we have our factory ball joints installed, we're going to reinstall our factory aluminum knuckle for the JL for this series. A little bit different design than the JK. Slips in right here behind the knuckle. Now that we have our unit bearing torqued down, the boot is seated all the way in its final position. I'm going to reinstall our axle nut. So this is our complete JL Dana 44 ProRock, complete with RCV shafts, factory ends, 513 with an ARB, ready for the trail.
There it is. Bum, bum, bum. Tony and Steve just rolled in our brand new axle, and now they're going to start bolting it up to our JL. Look how shiny it is. And that, my friends, is how a Dynatrac ProRock 44 is made and installed. Certainly, it's far from being something that everyone needs, and I would even go so far as to say that most will never need. Churching it up and convincing you of otherwise is not the reason why we decided to make this video series. Okay, full disclosure. Clearly, Jim McGee, the owner of Dynatrac, is a close and personal friend of ours, and he did help us get a ProRock axle for our JL. But the real reason why we wanted one is not because of that. It's because of the experience we've had running them on all our Jeeps over the last 10 years. It's the thousands of miles of use and abuse that we've put them through, such as on Moby's ProRock 60, ProRock 80, and RubyCat's XT60 and ProRock 44 before that. However, I wouldn't want you to take my word for it. Instead, I would encourage you to check out the myriad of videos that we've been making since 2007 and see for yourself just how strong and reliable all of our Dynatrac axles have been for us.